In this video, we are going to solve by factoring. So first, we're going to remember that if I multiply two numbers together and the answer is 0, that implies that one of the two numbers I multiplied together is 0. So we're going to factor out a polynomial, and then we're going to set each factor equal to 0, and one of those statements would have to be true. So however many factors we have, in this case it's going to be 2, set them equal to 0. X has to be one of the two values to make that factor equal 0. Said that really fast. It'll be easier to understand when we look at an example. So question 28 here, we have a trinomial, quadratic trinomial. So I'm going to start off with my normal process of x squared is x times x. Because it's a minus 24 on the end, I know I'm going to get a 1 plus and a 1 minus. Now I need my factors of 24. I can do 1 and 24, 2 and 12, 3 and 8, 4 and 6. It's going to be one of those groups. But because we have the minus 5x, I have to pick the factor group that has a difference of 5, which is this one. So I'm going to put a plus 3 minus 8, specifically so that when I do my FOIL process, I get a negative 8x for the outside plus 3x on the inside to get that negative 5x in my standard form. So now I have my two factors, factor 1 and factor 2. Factor 1 times factor 2 equals 0 means factor 1 equals 0 or factor 2 equals 0. Solve each of these. So for the red one, I subtract 3. For the green one, I add 8. X can't be both of those at the same time. So as far as solutions go, it's one or the other. In 29, we're going to start by factoring out a GCF first. All of those numbers are even, so my GCF can be 2. I'm left with an x squared minus 5x plus 6. I keep the 2. The 2 is still a factor, but now I'm basically just in the same process I was above. So I have the x squareds. My factors of 6 are 1 and 6 or 2 and 3. They're going to have to add up to a 5, but they have to both be negative, so negative 3 and a negative 2. If I check by foiling, x times x gives me the x squared. X times minus 2 is minus 2x on the outside. Negative 3 times x is negative 3x on the inside. That makes a negative 5x overall. And negative 3 times negative 2 is positive 6. So this is my factoring. So I have factor 1, factor 2, and factor 3. Technically, one of those factors would have to equal 0. So either 2 equals 0, which does not happen, x minus 3 equals 0, or x minus 2 equals 0. I still checked that 2 equals 0. It sounds silly, but I'm not losing that factor this way. If I just wrote x minus 3 times x minus 2, that is a different polynomial. It's something different. So make sure you have that GCF term. In this case, I'm going to end up with x equals 3 or x equals 2. Okay, add the 3, add the 2. And then for number 30, I'm also going to start with my GCF. This time my GCF is 3x. That leaves with a 3x minus 1 equals 0. This is not any more difficult than question 29 because it's still GCF, set factors equal to 0. But every year, students are going to struggle with this sort of idea because 3x can equal 0. 3x minus 1 can equal 0. They're both factors. 3x is a factor even though it's just a monomial. I don't need to always have an x plus a number or x minus a number. If it makes you feel better, you could call it 3x plus 0, and then you'd be good to go. Divide both sides by 3 in the red gives me x equals 0. 0 divided by anything outside of 0 is 0. And for the green, I'm going to have to add 1 to both sides, then divide by 3 to get a fraction as my answer. So make sure when you're solving by factoring, you keep all of your factors, set all factors equal to 0, and then if there's no x, that one's not 0. And then if it is x, you solve for x just like you would, and it's going to be a two-step process pretty much every single time. Have a great day, everybody.